What's up, Dune Wizards? Welcome back. Another day, another query. Or you could be binge watching the series, and to that, I applaud you. In this video, we will write our usage and activeness query together to see how safes are being used in terms of frequency, volume, and even category like stablecoin versus non-stable coins. If you have no idea what I'm talking about, go watch this video linked above and start there. Okay, let's go do some SQL workout. So we said that we are going to do usage and activeness. We are just going to copy paste these definitions that we want. Also here we have a link to a query, which just standing on the giant's shoulder of Cartod. Sorry if I'm mispronouncing it. Basically, we list all the stablecoin addresses here for our later usage. Let's go start a new query. Going to go on Dune SQL. Per usual, starting a comment block. When we look at the usage and activeness, we are going to look at the usage and activeness in the past 3 finished months. So today is February 17th. So I'm looking at January, December, and November. So it does not include a month that's not finished. And in terms of frequency, we want to get the total number of transactions, average monthly number of transactions. In terms of volume, we want to get the total USD volume, the average monthly USD volume, and the percent of volume in the stable coin versus non-stable coin. And we have this query, which we are going to go back to here. I'm going to copy paste here for us to use. Okay, let's see. So now is the step where we write down our logic. Step 1, we want to define safes we are investigating. This would be taking the safes that are created in the past 6 months, like we did in the previous query. After that, we want to look at the transaction side of things. So transaction side of things for frequency. Basically here, we want to count how many transactions in total have passed through this safe. So now let's look at volume side of things. We want to look at volume, then we need to get the token flow. So we need token flow for ETH and ERC20 tokens. And we want to also make sure that in and out flow are both counted as positive numbers because we care about the entire liquidity and not the net flow. Here we're going to say absolute USD value, USD value. To do that, for ETH, we're going to just track the value, but for ERC20, we're going to track the transfer event. Then to adjust USD price, we're going to use the prices.usd table. And then we will put everything together. Awesome, let's get to it. Step 1, we want to grab all the safes that were created in the past 6 months. So with safe addresses as, what are we looking at? So I forgot what query would get us that, but we have the query from yesterday, so we can quickly refer to that. So query, this is what I'm looking for. Select from this query, what are we getting? We want to have the safe address from this query, and then we want to limit to the past 6 months. So where creation time is greater than now minus interval 6 months. And down the road, we can definitely parameterize this to make it more flexible. Next step, we want to get the transaction side of things. So let's start ACTE for that. Transaction as we are doing a select from Ethereum.traces. Why am I using the traces table? You could just look at the transactions table, but there could be a lot of internal transactions that are triggered by the top level transactions. So I want to be able to take into account of those. So I want to have all the transactions that have in general passed through the safe and not just the ones that directly started with the safe. So that's why I'm doing traces. Now let's do filters where, so I want to only look at successful transactions. So transaction is successful. Then next I want to look at all transactions that have passed through the safe. So where 2 and 2 in, but now I'm recognizing that safe addresses, there's a lot of them. So I want to make it more optimal. So I'm going to say where it exists, select one from where safe address is equal to 2. That's how we are filtering for the transactions that have passed through safe. If you're wondering, okay, generally when we track things, we track both from and to, and why are we not doing from here? It's because the safes are account abstraction. They are actually a smart contract, so they cannot actually initiate a transaction themselves. It makes our job easy. Actually, we only need to track the twos here. Now let's do the time filtering. So block time is, we said that we want to look at the past 3 months that are finished. How do we get that? First, we need to get the current month. We need to get date trunk, and then we need to get the month right now. So this is the current month. And then we want to go back in 3 months of the current month. What do we do? There is a date add function. And we're saying we want to add month, right? We want to add month. And then what are we doing? We want to minus 3 months from the current month. That's how we will get the past 3 finished months. Okay, then we just need to get the current month, which we already have here. So it has to be less than the current month. Then we're good. Now we need to see what we want from here. So we want the 2 as the safe address. Then we want to count the transactions that have passed through. We want to count the transaction hash, but normally we could do a count. But there's this function which would run faster when there's a lot of data. It's called approximate distinct count. So APX and then distinct and then that. So this would be our total prev in month num transaction. After that, we want to do an average. We'll just take this number and divide it by 3. We can make it a bit more sophisticated because not all safes are active in every single one of these months, but just for simplicity, we're just gonna do a simple divide by 3 because this count would be a integer number and 3 is an integer, and in Trino SQL when you do integer division it would round it up for you. Here we're going to force one of the integers to be a double so that it actually gives us a decimal result. Okay, we're going to say we're casting this approximate distinct count to be a double. Then we are dividing that by 3, so that is our average monthly num transaction. Then last step is we need to do a group by 1 because we care about the safe addresses individually. So let's do a QA check. Let's check it quickly. So this has 182 transactions, so let's go see if that's true. Okay, so lots and lots of transactions. Sanity check works out. Let's just check one that only has 1. That is probably when it was created. Let's see. Yep. Moving on to the volume side of things with volume as. Here we said that we need to look at both ETH and ERC20. Let's just do it one by one. Let's start the ETH block. Okay, with ETH volume as, instead of that, we want to take into account of in and out. With ETH in as, what are we doing here? Select from what table do we need? There is a transfer Ethereum table we can actually use. It is a spell, so let's find that. Transfer, and then here we do an ETH. This is an abstraction built on top of Ethereum traces because we have this wonderful spell. Why not use it? If you want to take a quick look, this is what it looks like from to what is the value, and it even adjusts the decimal for you. With that, we want to get to in, so we want to get to the safe address is transferred to as safe address. Then we want to sum up the value in decimal amount. So sum up that as the ETH amount. And then also here, let's just start aggregating on a weekly basis. So date trunk week, and then transaction block time as our time. Let's filter this. So where the twos should exist in the list of addresses that we care. So where it exists, select one from, basically I am going to copy what we have up there. Okay, and then only caring about the past 3 finished months. So same trail as above, except now this is named transaction block time instead of block time. So just slightly changing the name, and we are going to group by the week. So that would be our ETH in, and let's just do an ETH out very similarly. So ETH out is the same thing, except we change the to be from because it's flowing out from that safe address. Here we also do that, and we put double quotation because from is a keyword. Next step, we need to combine in and out together. So we're going to do an ETH both as, so select star from ETH in, and then union all. So we are vertically joining the two, then we're gonna sum it up. So from ETH out, that's our ETH both, and then the last step is to sum it up. So we want to have the safe addresses, and for each of the safe addresses we want to sum up the ETH amount, and this would be the amount for this token, our ETH. So from ETH both, and then we want to do group by each of the safes. This is quite a lot of data that we're running. Let's just do a sanity check with a test safe. I'm going to do this, and then to create a test data, I'm going to create the same temporary table, but then give it column name address. Then just going to randomly pick a safe address that we're creating in the past 6 months. So we're going to do just an address that I found. We're going to do QA here, and then we're going to comment out this one. So with this safe address, we want to track its ETH volume. So select star from volume. Should only have ETH right now. Oh, looks like we've got an error. Why is that? Oh, need to select from ETH. So need to do select star from this. Too many nested parentheses. Safe address cannot be resolved on line 39. Oh, I named the column wrong. It should be safe address as the column name. Oh, okay. This is, don't need this. Don't need the S's there. Schema does not exist. Oh, wait, what? Oh, okay. That's my mistake. That should be good. Okay, so 2 must be in an aggregate expression or in a group by. So group by 1 and 2. I think similarly forgot to group by 1 and 2 here. Okay. Well, turns out the QA check was very, very necessary. Okay, so it's saying that 212 ETH has flown through. Let's just quickly check, see intuitively if it makes sense. Okay, so at least it has 700 ETH right now. Let's see. Does this make sense? Aha, internal transactions. A bunch of ETH, a bunch of ETH. Okay, this, sanity check passes. Next part we need to work on is the ERC20 block, right? And we basically want the same logic. Getting into ERC20 side of things, we are already in this transfer spell land. We can just go to the ERC20 transfer spell land, select from the transfers of the ERC20. We are going to call this T, and what do we want? We want to have the token address for this particular token, so we can adjust USD prices individually later. Then we want to grab the wallet address, which would be our safe address as safe address. And we want to get the value of the token. Okay, so there's a few things that we need to do. First, we need to adjust the raw amount to be the decimal amount. To do that, we need to find another spell. So we go to the tokens and then we go to ERC20. We are going to do a left join on the ERC20 tokens table, which we are going to call TK on what? So TK dot contract address should be equal to T dot token address, so they are the same token. And also want to make sure that we are only looking at the Ethereum tokens, so blockchain is equal to Ethereum. Once we have that, we can adjust for things. So we want to do divided by 10 to the whatever decimal, but sometimes decimal could be non-existent, so we want to give the default 18. So we are doing a coalesce function of tk dot decimal, and if that doesn't exist, then we're going to adjust it by 18 decimal. So that is that part. Let's go back to the transfer part of things. So in the ERC20 transfer, the amount is still a varchar, so we need to cast that to be a double. As double. Once we cast that, we will need to sum up this adjusted decimal amount for each of the token, right? However, so let's call that amount. However, we want both inflow and outflow to be counted as positive, so we need to apply an absolute function because we care about the volume instead of the net flow here. So the function that we need to apply is ABS for absolute. Next up, we need to filter on ERC20 transfers. We want to look at the wallet address is in the safe that we care about. So again, we're going to do a where exists one from. Let's copy this one more time. So where exists, select one from safe address where this is equal to, we want to have the wallet address, and then again we need to adjust for the timeline of things, so literally copy pasting the time here. And let's see, so it's called event block time, so we are going to slightly adjust the column name one more time. And then one last step, because we're summing up everything for the token for this safe address, we are doing a group by 1 and 2. And that would be our ERC20 volume. Let's just do a select star from ERC20 volume, and then select star from volume. Then let's do a QA check. Okay, I forgot an and. Let's run that again. Okay, so we have some results, looks fine. All right, next up, we need to join the ERC20 together with the ETH. Let's do that. Let's join the ETH together with ERC20. So joining ETH with ERC20, ERC20. Okay, we're gonna call this all assets as select from. We can do our ERC20 first. Before we select the columns, let's just grab the prices so we can adjust the USD volume later. Here we are grabbing the latest USD price and we're actually doing an inner join. Here we only want to filter for the tokens that have a USD price. One, we have pretty extensive token prices, and two, here I care more about the USD volume or liquidity. So if it doesn't have a price, it doesn't help me. That's why I'm doing an inner join, because normally we would do a left join. Calling this P, and then how are we going to join these things? We're going to join on P dot contract address is equal to, we're going to call this ERC20, so is equal to ERC20 token address. Then we're also going to say that p.blockchain is equal to Ethereum, so only want the Ethereum price. Now we are ready to grab whatever things that we need. So one, we want to get the token symbol so it's more human readable. We're going to say p.symbol would be our token symbol. Next, we want to get the token address. Then next up, we want to get the safe address, ERC20.safe address. Then we want to get the ERC20's amount here that we saw. This would be the native token amount. So we would name it native amount. The next part is we are going to time it by the price, p.price. This would be our USD price. Also, just because we already summed it up in the previous step, so here let's just call it some native amount and some USD amount. One more thing, we did say up top that we want to know more about what category of volume, so that whether it's stablecoin or non-stable coin. So here we can see these are the contract address for various stable coins. So we're going to take this query ID and we are going to do a case statement for the volume. We're going to do case when the token ERC20 dot token address. So when the token address is in the contract address from this query that we just saw, then it's a stable coin. Else, it's a non-stable coins. And we can end as category. So this way, when we are later sum things by groups, we can see the volume for the stablecoin group and the volume for the non-stable coin group. That's what we need for the ERC20. Then we are going to, per usual, do a union all to get the other side of things, the ETH side of things. To begin with, ETH would be our token symbol, and then we're selecting that from the ETH volume side of things, so we're going to call that ETH. And then the same thing, we need to do that joining on the prices, so we find the USD for this ETH. But differently though, we want very specific contract. So we want the wrapped ETH contract address because we're using wrapped ETH for ETH price. So I still don't remember the wrapped ETH address after all these times. Going to just go grab the address for wrapped ETH and then put it here. So we are using wrapped ETH for ETH price. Here need the token address. So for token address, we're going to use the 0xe. So there's a bunch of ETH. I'm just going to copy this from an older query that I have. This is just a placeholder for ETH token address as token address. And then we need the safe. So safe address So same thing here. ETH is a non-stable coin, so for sure we can just say non-stable coins as category already. Then the native amount is ETH dot amount as some native amount, and then the same thing, ETH dot amount times P dot price here, yep, as the sum USD price. With this, let's just see what this goes for this one address. So select star from all assets, and let's do some QA check here. Schema does not exist. ETH volume, oh, I guess it does not exist. What was it called? ETH vol. Okay, so let's just call this ETH volume. Let it run one more time. Okay, we've got some result. Looks as expected. We saw ETH and then we saw USDT and USDC previously. Looks good to me. Let's sum this up to be what we want in terms of volume. We want to select the safe address because that's what we're anchoring our analysis on. So from all the assets, and then definitely need to do a group by one because again, that's what we're anchoring on. We want to first sum up the total volume in the previous finished 3 months. So we're going to sum up the volume of all these tokens. We're going to do a sum of the sum USD amount. I think we set that. Oh, okay. This is a mistype of column names. So we're gonna do USD amount. Don't know why I did not catch that earlier. Okay, this would be our total prev in month USD volume. Then same thing, we're gonna just divide this by 3 to get the average. Okay, so this would be AVG, and then we can just make this simpler. Monthly USD volume. Next, we want to find the percent of volume that is in stable coins. Let's do case statement. So case when and then end as basically percent volume stable coins. Okay, stable coins. We want to filter for when there's no stable coin, then we can directly assign the percent as 0. So we are going to say when the sum of the USD amount filter. So this is a different syntax we're introducing. So we can filter on a aggregate function. So we're filter for what we have this category here. So we're filtering for where category is equal to stable coins. In this case, if that is 0, or because it can be null, because if there's no stable coin, then it will just be null. So if this is null, then we're going to directly assign 0 for the percentage. Else, if the non-stable coin is 0 or the non-stable coin is null, then that means everything is in stable coin. So it's 100% in stable coin. Otherwise, just kidding. So this is when, not else. Else, we can do a division. We would do some USD amount filter for the stable coin. Let's put this in a parenthesis just in case. Divided by the sum USD amount already. That would be our percent volume stablecoins. Okay, that's all we need from the volume side of things. We can just quickly verify. So here we're expecting definitely some stablecoins, some non-stablecoins. Let's run it and see. Okay, let's see. So percent of stablecoin volume 17% makes sense, and then the previous is, and then average. Okay, this all makes sense. Now is the part where we join the volume and transaction together and finish up the query. We are going to do select from the transactions T, right? And then we're gonna do a left join on the volume table. V on T dot safe address is equal to V dot safe address. We want the select t.safe address. We want the safe address. We want the transaction frequencies, right? So t.total private month num transaction. Obviously, we want the average num transactions, and then we want the v.total volume, and then we want v.average volume. Okay, we've done QA check in a lot of steps. We can uncomment the actual saves, all the saves that we want to look at, and comment out the particular save we're looking at. Then we can run. Schema does not exist from transactions, really? What did we call it? Oh, we called it transaction. Okay, transactions, fine. Let's do it. Okay, gonna save it. We have our results for all the saves that were created. Actually, forgot to grab our percentile volume stablecoin. Oops, so my bad. But let's do that quickly. Let's just run it again. But that is it for our second query on activeness and usage stats. Okay, so see you in the next query. Bye.